Hi, today we are going to do an exercise on dropout and batch normalization. We'll add dropout to the Spotify model from exercise 4 and see how batch normalization can let us successfully train models on difficult data sets. The first part is setting up the libraries and the plotting things. So the next part is that we are loading the Spotify dataset. We are dropping the rows which are having null values. Our target is a track popularity column, and we use a track artist to do something which we'll explain later. These are our numerical features followed by our categorical features. We would pre-process the data before we pass on to the neural network. Therefore, what we do is that we scale the numeric features and we one-hot encode the categorical features. Next, what we do is that we do a group splitting, which means that based on the artist column, that is the track artist column, we ensure that the artist which is in the train set is not in the test set, and the artist which is in the test set is not in the train set. This is to ensure that the model is not biased. Now, in the next step, we pre-process the both the training and the validation set. We scale the train and the validation set. After doing all these things, what we have is an input shape which is of 13 columns for the training data set. Now here we add dropout to the layers. You see that there is a dropout of 30% which will be applied to the next layer, and similarly we add a dropout to the next layer. So this is a code for it. Now we do this same thing again, that is compile with the optimizer Adam, and the loss is a mean absolute error. We fit the model and the batch size is 512, the epochs is 50, and we plot the history object which contains the training loss as well as the validation loss. And we can see that the validation loss does not increase a lot. Now, it is an improvement over the models that we have discussed in our previous exercise, because what would have happened is that the validation loss is not increasing and it is not learning, it is not overfitting a lot. So this is a advantage of adding the dropout here. Now next what we will do is that we will do the batch normalization. We will choose the concrete data set and we read the concrete data set, we do a train and a validation. 70% is training, 30% is validation, and our target variable is compressive strength. And what we do is that we have a 1500 neuron neural network with a dense layer, and this is without the batch normalization. What we see here is that we compile with SGD with MAE, and the matrix is also MAE, and we fit the model and we plot the loss and the validation loss. Here we see that it is having a blank graph, so it's not doing it well, right? So what we do now is that to correct this, we add a batch normalization layer. So we add a batch normalization layer before each dense layer. So this is a batch normalization layer before this dense layer, and similarly which you can see in this. So the batch normalization layers are added. We train the model and we train it with 100 epochs, and we see that this is helping a lot, and you can see now the loss functions. So it was a big improvement on the what should I say, without adding the batch normalization. So hope you liked it. Thank you. Bye.